Alright guys, today we are going to be working with negative and zero exponents. Very similar to what we've been doing the last couple of days, but there's a little bit of some differences here. So for our warm-up today, we're just kind of reviewing. If we're multiplying exponents, we keep the base the same, and we add the exponents. So x to the fourth times x to the second becomes x to the sixth. A to the fifth times a to the negative second. 5 plus negative 2 is 3, so a to the third. And down here, b to the second times b to the negative fourth. B to the negative second. Now this is something that concerns us, and we're going to be learning about that today. So when we do our lesson today, we're going to be coming back to look at letter C here. Over here on letter D, x to the fifth divided by x to the third. If you're dividing, you subtract the exponents, so x to the fifth minus x to the third becomes x to the second. And a to the fourth becomes a to the 0 power, and we learned yesterday that anything to the 0 power is 1. And then we have this one, b to the 7th over b to the 9th. We know our bigger b is on the bottom, so we leave the b's on the bottom. 9 minus 7 is 2, and I put the 1 up here on top. So that is my review. Alright, let's take a look at some of these a little bit closer. We talked about 0 to the 0 power, or anything to the 0 power is 1. If you want to plug something in there, what if a was 2? Plug it in there just to see how that works. 2 to the 4th power equals 16. 2 to the 4th power equals 16. Well, 16 divided by 16 is 1. So if I have 2 to the 4th divided by 2 to the 4th, 4 minus 4 is 0, so 2 to the 0 power is 1. And that works for any number. As long as your exponent is 0, your answer will be 1. Here is the one that we did with the b to the second. We left it on the bottom. Well, b to the 7th divided by b to the 9th, if I were to subtract that, 7 minus 9, that is negative 2. So that negative 2, well, we actually move it down to the bottom, and that's what we're going to learn about today in our notes. So let's take a look. It says negative exponents are never happy where they are. They need to move to be happy, just like people. Once they're happy, their negative nature melts away. So whenever you see a negative exponent, shake the term up a little bit, help it make some changes in its life, and move it to the reciprocal position. Reciprocal, big word. To take away its negative thoughts and make it have a positive attitude. Reciprocal. If you guys remember when we talked about dividing fractions, if you were dividing, you would actually multiply by the reciprocal. So if I had 1/2 divided by 1/3, I would actually multiply by the reciprocal. I would multiply 1/2 by 3 over 1, and I'd get 3 over 2. So when I did the reciprocal, I just kind of flipped the top and the bottom. I flipped their places. So the 1 went to the bottom, 3 went to the top. Same thing over here with our little diagram here. If I have any negative exponents are bad, they're not happy, so they need to move to their reciprocal position. So I would take this y to the negative third, and I'd move it to the bottom, and it becomes y to the third. It becomes positive. When you move it to the reciprocal position, it becomes positive. Same thing with the z. Z to the negative fourth, I don't want the negative, so I'm going to move it down here into this bottom. It becomes z to the positive fourth. Up here, or down here at the bottom, I've got negative 4, so I'm going to move it up to the top. It becomes positive 4. And my z to the negative fifth, move it up to the top, and it becomes positive 5. So now that I've moved them, I can simplify them. I can go ahead and multiply the tops, multiply the bottoms, and combine things that are the same. So here I have x to the second times x to the fourth. Well, that ends up being x to the sixth. And then I have z to the fifth. It just stays right there for now. On the bottom, I have y to the third times y to the second. That becomes y to the fifth. And then z to the fourth on the bottom. Well, I can still get rid of these z's here. If I have the bigger z is on top, 5 minus 4 is 1. So I'd cancel out 4 of them. Cancel out 4 of them. That would make it just left with 1. So my final answer would be x to the sixth times z over y to the fifth. We're going to do a couple more examples so that we make sure that we understand. So here is what we learned. 0 exponents, anything to the 0 power is 1. And negative exponents, any number to a negative power is in the wrong position. Move it to its reciprocal position and it becomes positive. Never leave any negative exponents in an expression. And that's what we need to make sure that we remember today. So let's practice a little bit here. 6 to the negative second. Well, I am going to take it and I am going to move it to its reciprocal position. So if right now it's on the top because it would be like over 1. If I'm going to move it to the bottom, it would become 6 to a positive 2. And I can't leave the top empty. I have to change the reciprocal here, so I have to move the 1 to the top. So 1 over 6 to the second power. And we're not going to actually evaluate today. I should actually just change this to simplify. I'm not going to make you go through and actually do the work down here. We're just going to simplify them. So letter B, negative 3 to the negative 5th power. Once again, if there's nothing below, there's no fraction. It's like having it over 1. Over 1. So then I do the reciprocal. 1 over negative 3 to the positive 5th power. And I want to make sure I have positive exponents. And that would be my answer that I'm going to stick with. Letter C, 13 to the 0 power. We know anything to the 0 power is 1. Letter D here, 3 to the negative second times 3 to the negative 5th. Well, on this one, I'm going to simplify first, and then I'm going to move it to its reciprocal position. So 3 to the negative second times 3 to the negative 5th, I'm going to add the exponents. Negative 2 plus negative 5 becomes 3 to the negative 7th. Now I'm going to move it. So I would have 1 over 3 to the 7th. I'll try to fix that. 1 over 3 to the 7th. And that is my answer. Okay, moving on to some little tougher ones here. Same thing I did on the last one. I'm going to simplify first, and then I'm going to move. So x to the negative 7th plus 4. Negative 7 plus 4 is negative 3. And now simplify. 1 over x to the 3rd. Letter F here. W to the 6th times w to the negative 6th. Add the exponents. 6 plus negative 6 is 0. So w to the 0 equals 1. Over here, I can do either way. I can move it down first to make it happy and then simplify. Or I could do my simplifying first. In these kind of examples, I like to move them first to make them happy. So if I moved this x to the negative 3rd down to the bottom, it would become x to the 3rd. And then there's a 1 left up on top. So now I can simplify. X to the 5th times x to the 3rd becomes x to the 8th. Over here on letter H, same thing. My 3, if there's coefficients out here, I'm going to simplify my, separate them from the variables and then do those first. Can I simplify 3 over 1? No, it's already simplified. Just leave it as 3. Then I have this x to the negative 4th. I want to take that x to the negative 4th. It's not happy up there because it's negative. Move it down here to the bottom. So on the bottom, I'm going to have x to the 6th and x to the 4th. Simplify that. X to the 6th times x to the 4th becomes x to the 10th. So 3 over x to the 10th. Another couple examples here. 24 to the 24w to the negative 5th, 6w to the 2nd. I'm going to separate the numbers from the letters. Simplify this first. 24 divided by 6. I can divide them both by 6 and I get 4 over 1. And now I do my simplifying over here. My w to the negative 5th is going to move down with my w to the 2nd. So w to the 2nd, w to the 5th. Simplify even further. The 4 stays up on top. W to the 2nd times w to the 5th is w to the 7th. And if I want to put the little 1 in there, I can. I don't need it there, so I'm just going to leave it as 4 over w to the 7th. This next one. On this one, I'm separating the numbers from the variables. And here, I actually have my number raised to the negative 3rd power. So on this example, my x is just going to stay up there on top. And I have 2 to the negative 3rd comes down, becomes 2 to the 3rd. And my 2 to the 5th stays there. So I can simplify this. X over 2 to the 8th. And the last one here. Separate to help me out here. 8 to the negative 4th is going to go to the bottom with the 8 to the 2nd. becomes 8 to the positive fourth. Over here, the u to the comes to the bottom with the other u, so u to the 7th and u to the 2nd. What's left on top? A 1. Now I can simplify. 1 over 8 to the 6th, u to the 9th. Okay. Take a look at these. You're going to have some like this on your homework. These are making you think about